Okay, we're trying some more examples with the secant and cosecant function. Here we're being asked to draw a graph of the cosecant function, and we have to label all zeros, maxes, mins, and asymptotes and identify the period. So the key thing to remember here is that cosecant of theta is 1 over the sine of theta. So really this comes down to understanding the graph of sine of theta very, very well. And so I'm going to start with a graph of sine of theta, and that's probably a graph that you should have already memorized. So my graph of sine of theta goes up to 1 and down to -1. Starts at 0, goes up to 1 at pi over 2, down to 0 at pi, down to -1 at 3 pi over 2, and back to 0 at 2 pi. Let me draw a loop on the left of the axis as well. So what I've drawn there is not cosecant yet, it's sine theta. And now in red, I'll draw cosecant of theta. So cosecant of theta is just 1 over sine theta. So wherever sine is 1, it's 1. Wherever sine is -1, it's -1. And then whenever sine is 0, well, you can't divide by 0, so that's where cosecant has an asymptote. So it goes up to infinity wherever sine goes down to 0. And down to -infinity wherever sine goes to 0. So it looks a lot like the graph of secant did. It's got these u's going up to infinity and these upside down u's going down to -infinity, depending on where the graph of sine hits 0. So let's label everything we've been asked to label here. Cosecant theta never crosses the x-axis, so it has no zeros. So there are no zeros to label there. Maxes and mins, it has local mins at the bottom of each of these u's. This is at pi over 2 and 1, that's a local min. And then we have local maxes at negative pi over 2 and -1, that's a local max. And another one at 3 pi over 2, -1 is a local max. So we've got the maxes and mins. The asymptotes are the places where it goes up to infinity and down to -infinity. So let me label those. There's one right there at -pi. Here's another one at 0. Another one at pi. And finally, here's one at 2 pi. Basically, those are the places where sine of theta is 0. Remember, cosecant is 1 over sine theta, so wherever you're sort of trying to divide by 0, that's where cosecant blows up to infinity or drops down to -infinity. So we've got the asymptotes. Now the period of the cosecant function is how long it takes to repeat itself. So that's one period before it starts repeating itself, and that's 2 pi. And that really comes back to the fact that sine theta has a period of 2 pi. So the period of cosecant, just like secant, is 2 pi. Okay, looks like we answered everything there. The key part there is that it's remembering that cosecant is 1 over sine. So you probably don't need to memorize the graph of cosecant itself. It's good if you're kind of familiar with this general shape of the u's going up and the u's going down, but you probably don't need to memorize the details as long as you remember that it's 1 over sine and you can work it out from that.